Hi everyone. In this video, I'm going to discuss the classifications of embedded systems based on the performance and functional requirements and based on the performance of the microcontroller. Here's what you'll find in this presentation. Basics of embedded systems, classification of embedded systems based on their performance and functional requirements, classification of embedded systems based on the performance of microcontroller. So let's get started. The basics of embedded systems. So based from our previous videos, so you should be able to understand or you should be able to define what is an embedded system. So an embedded system is an electronic system that has a software and is embedded in computer hardware. It is programmable or non-programmable depending on the application. In embedded systems, all the units are assembled and work together according to the program. So some examples of embedded systems includes numerous products that we have that we're using in our daily life, so such as microwave ovens, washing machines, printers, automobiles, cameras, etc. So these systems use microcontrollers and microprocessors as well as microprocessors like DSPs. And embedded system has three main components. So that's the hardware, software, and operating systems. Okay, so actually there are two types of embedded systems, and it can be classified based on their performance and functional requirements, and also the performance of the microcontroller. Okay, so let's start with the based on their performance and functional requirements. So later on, we will just also discuss the performance of the or based on the performance of the microcontroller. So let's start with the based on their performance and functional requirements. Okay, so in the classifications of embedded system, which is based on the performance and functional requirements, so we have four classifications: the standalone embedded systems, real-time embedded systems, network embedded systems, and mobile embedded systems. Let's start with the standalone embedded systems. In standalone embedded systems, these systems do not require a host system like a computer. So it works by itself and it takes the input from the input ports, either analog or digital, and it processes or calculates and converts the data and gives the resulting data through the connected device. So which it either controls or drives and displays the connected devices. Okay, so an example of the for the standalone embedded systems are MP3 players, digital cameras, digital wristwatches, video game consoles, and microwave ovens. So I think some of these devices or examples, maybe you have already used those devices already, and I know that you know that it doesn't need a host in order for it to run. Okay, so the next one is the real-time embedded system. So real-time embedded systems follow the time deadlines for completion of a task. So it is classified into two types, and those are the soft and hard real-time systems. Okay, so soft real-time systems and hard real-time systems. So these types of embedded systems provide a quick response in critical situations, which gives most priority to time-based tasks, performance, and generation of output. So that's why real-time embedded systems are used in defense sector or even in medical and healthcare sector. Well, of course, in some other industrial applications where output is the right time or in the right time is the utmost important. So some real life examples are the traffic control systems, medical systems for radiation therapy, and some manufacturing systems. Okay, so the next one is the network embedded system. So these types of embedded systems are related to a network to access the resources, and the connected network can be LAN, WAN, or the internet. Okay, so the connection can be any wired or any wireless connection. So this type of embedded system is the fastest growing area in embedded system applications. And the embedded server is a type of system wherein all embedded devices are connected to a server and accessed by a web browser. So an example of a LAN network embedded system is a home security system wherein all sensors are connected and run on a protocol, which is the TCP/IP. And I think another example is the ATM machine and also the card swipe machine. So those are the examples of a network embedded systems. Okay, so the last one is the mobile embedded system. So mobile embedded systems are used in portable embedded devices. So like cell phones, mobiles, and digital cameras. So it's like a standalone embedded system. So MP3 players and personal digital assistants, etc. They are also an example of a mobile embedded systems. So they are the most preferred embedded systems nowadays. Okay, so that's for the classifications of embedded system based on their performance and functional requirements. Okay, so let's go back to our selection of types of embedded system. So the next one is the based on the performance of the microcontroller. Okay, so in the classification of embedded systems based on the performance of the microcontroller, so we have three: the small scale embedded system, the medium scale embedded systems, and the sophisticated, or in some other resources we have the complex embedded system. Okay, so let's start with the small scale embedded systems. So these types of embedded systems are designed with a single 8 or 16-bit microcontroller, so that may even be activated by a battery. So for developing embedded software for small scale embedded systems, the main programming tools are an editor, assembler, or cross assembler and integrated development environment. Okay, so we're using IDEs in order for us um, to make to as the main programming tool for this types of embedded system. Okay, so the next one is the medium scale embedded system. So medium scale embedded systems are designed using a 16-bit or 32-bit microcontroller, and these medium scale embedded systems are faster than that of a small scale embedded systems. And of course, integration of hardware and software is complex in these systems, and it uses Java, C, and C++ as the main programming language that is used to develop these medium scale embedded systems. So different types of software tools like compiler, debugger, and simulator, etc. are used to develop these types of systems. Okay, for the last one is the sophisticated or complex embedded system. So these are designed using a multiple 32-bit or 64 bit microcontroller. So these systems are developed to perform a large-scale complex functions. So these systems have a high hardware and software complexities. So we use both hardware and software components to design the final systems are of this or hardware products, this type of embedded system. Okay, so that's for the classification of embedded systems based on the performance of the microcontroller. So in summary, uh, independent functionality of in the standalone embedded system does not apply to all embedded systems. So many embedded systems are functional and purposely only as integrated parts of a larger mechanical or electrical or electronic systems. So if embedded systems are part of or rely on networks or other devices in order to function, so they are classified as a network or networked embedded systems. And then an important thing for you to remember, all mobile embedded systems are standalone embedded systems. But not all standalone embedded systems are mobile embedded systems. Okay? So small scale embedded systems have an 8-bit or 16-bit microcontroller. Medium scale embedded systems have a 16-bit or 32-bit microcontroller, and sophisticated embedded systems have multiple 32-bit or 64 bits. It should be 64-bit, not 62-bit, 64-bit microcontrollers. Okay, so that's the summary of our um, presentation. Okay, so that's all for now. So if you have any questions or clarifications, you can just email me, and that would be all for now. Thank you, and see you on the next video.